If you're looking to land a job in IT, automation, or DevOps, then what we're about to cover is, well, it's pretty much non-negotiable. We're talking about the absolute bedrock of how Python code actually works, control flow. So yeah, let's just dive right in and get you from beginner to truly job ready. But first, let me ask you something. Have you ever really stopped to wonder how a program thinks? How does it go from just being a dumb list of commands to something that can react, make decisions, and, well, adapt? That's the big question we're going to answer today. And the answer is control flow. It's that simple. This is how your program makes all its decisions and controls the order that things happen. Honestly, it's the brain of your code. It's what turns a list of instructions into real dynamic logic. So here's our game plan. We're going to start with the basics of making decisions, then we'll get into repeating actions with loops. After that, we'll see it all come together in a real-world script. And then, this is the important part, we'll cover the key differences between beginner code and pro-level code and finish up with your clear next steps. Okay, first up, making decisions in code. This is where we literally teach our program to look at a situation and choose the right path forward. Just like we have to do every single day. The building blocks here are actually wonderfully simple. It all starts with an if statement. That's your main condition, your first check. Now, if that turns out to be false, you can have one or more elif statements, which is just short for else if. Think of these as your backup plans. And finally, you've got else. That's your ultimate fallback, the thing that happens if none of the other conditions were met. And here's a really important thing to understand. Python is super efficient. It reads your conditions from the top down, and the very second it finds one that's true, it runs that code and then just completely ignores the rest of the chain. It's smart. This saves a ton of processing time, and it's a fundamental concept you've just got to get. And now for the golden rule. The one thing you absolutely, positively cannot forget. In Python, that little bit of white space, the indentation, almost always 4 spaces, it's not just for making things look pretty. It's syntax. It's how Python knows which code belongs to which if or else. If you get this wrong, your code just, well, it won't run, period. So how do we actually form the questions inside our if statements? Well, we use these things, comparison operators. They're basically the grammar of our decisions. You'll use the double equal sign to check if two things are the same, the exclamation mark equals to see if they're not the same, and so on. Seriously, take a good look at these. You'll be using them every single day. And the result of any of these is always going to be a simple true or false. But, what if you need to check more than one thing at a time? That's where logical operators come into play. And is the strict one, it needs both conditions to be true. Or is way more relaxed, it just needs one of them to be true. And not just flips the result from true to false or false to true. Getting these down is how you build really complex, real-world logic. Now here's a really cool Python shortcut called truthy and falsy values. You can see on the slide some things like the number 0, or an empty string, or an empty list. They're all considered falsy by default. This lets you write much cleaner code. So instead of writing something clunky like if len mylist is greater than 0, you can just write if mylist. It's cleaner, it's easier to read, and it's very Pythonic. Okay, so we've taught our code how to think and make decisions. Now let's teach it how to work. And this brings us to our next huge concept, repeating actions with loops. This is where the real power of automation comes from. You've really got 2 main types of loops to work with. The for loop on the left is like an assembly line. You have a specific set of items, like a list, and you do the exact same action to each one by one. The while loop on the right is different. It's more like a guard on duty. It just keeps running as long as its condition stays true, and it only stops when that condition finally changes. And let me be really clear about this. In the world of IT and automation, the for loop is your absolute workhorse. Looping through a list of servers, processing a folder full of files, checking a bunch of user accounts. This is what you will be doing all day, every day. But hey, you're not just along for the ride in your loops, you're the one driving. You have control statements. First, there's break. That's your emergency stop. It just kills the loop immediately. Then you have continue, which is like a skip button. It ignores the rest of the current item and jumps straight to the next one. And finally, pass, which literally does nothing. It's a placeholder telling Python, hey, I'll figure this out later, which is actually way more useful than it sounds. All right, theory is great and all, but let's see how all this stuff actually comes together. It's time for some real-world Python, where we're going to build a script that you could totally use on the job.
Okay, so here's our scenario. We're the system admins, and we need to run a quick health check on all of our company servers. Are they online or offline? It's a classic automation task.
First things first, we need our data. In this case, it's just a simple Python list that has the names of our servers. We've got Web1, Web2, and our database server DB1. Easy enough. And here it is. This is where it all clicks. The for loop starts and it grabs the first server, Web1, from our list. Then all the indented code inside the loop runs. The if statement checks the status. If it's online, it prints that the server is running. Then the loop starts over for Web2 and then again for DB1. Oh, and that little F before the string, that's called an F string. It's a super handy modern way to pop variables right into your text. This simple little script, this is the core pattern of automation right here. Now, look, writing code that works is one thing, but writing code that gets you hired, that's a whole different ballgame. So let's look at what it takes to go from beginner to pro. These are the red flags, seriously. Forgetting your indentation, using a single equal sign when you meant to use a double equals for comparison, or a classic, creating a while loop that just runs forever. These are the mistakes that immediately tell someone you're still new to this. On the flip side, this is what professional code looks like. The conditions are simple, easy to understand at a glance. The variable names actually mean something. See, this isn't about being clever. It's about being a good teammate. Professional code is code that somebody else, or you 6 months from now, can pick up and understand instantly. That's what gets you hired. Phew, okay, we have covered a lot of ground. So let's boil it all down into your immediate next steps, the stuff you need to master right now. Here it is, your job-ready checklist. Just burn these 5 skills into your brain. If you can write clean decision logic, loop through lists of anything, combine conditions with and or, control your loops with break and continue, and just see the structure of code by its indentation, then you have the fundamental toolkit for any automation job. This is exactly what hiring managers are looking for. So, you've got it now. You have the fundamental building blocks of programming logic. You have the brain, the muscles, and the rulebook. The only real question left is, what boring, repetitive task in your life are you going to automate first?